This is June06 from the resistor networks calculations, and this is question 6. Figure 6.1 shows two resistors of resistance R1 and R2 connected in parallel. The currents in and the potential differences out and the potential differences across each resistor are shown in figure 6.1. Let's scan in just a wee bit so you can see it a wee bit more clearly. Write down the relationship between the currents I1 and I2 shown in the figure. Now we've already done this in a previous question, so that's very straightforward. I1 is going to be equal to the sum of I1 plus I2. Sorry, I is going to be equal to I1 plus I2 here, and that's the principle of conservation of charge. And so we're going to write in here I is equal to I1 plus I2. Always use the same symbols that they have there. Don't be making up your own. And it's a conservation of charge principle. Or Kirchhoff's first law, you can also write in there. Okay, and then it says write down the relation between the potential differences V1 and V2 shown in figure 6.1. Name the conservation principle you have used to obtain this relationship. And again, if you look at this, that's really, if I turn it on its side, it's just a wee parallel circuit, and therefore the potential difference between each end of the branch is going to be exactly the same, and so they're equal to each other, and therefore we're going to write down that V1 is equal to V2. You could alternatively, and you'll see this in the mark scheme, that V1 minus V2 is equal to 0, or you could write down V2 minus V1 is equal to 0, and the principle is a conservation of energy. And that's actually Kirchhoff's second law. If you want to do that.